Hi, everybody. Thanks for coming. Yeah, I'm here from AVEVA, which is a small software company, 50 years old now. I'll explain a little bit more about that. And I'm head of a small group developing AR and VR applications. I'm here really to tell you about something called the immersive digital asset. So we've heard about the digital twin and how companies going towards a sort of digital future are trying to create and manage the digital twin. Well, I want to share with you some insights that my team have learned about making that digital twin accessible in AR and VR applications. So a little bit of background just so you understand where I'm coming from and the kind of projects that our customers work with. So who knows what this is? And don't say a teapot. This is the Utah teapot, sorry. Which is something developed by one of our sort of founders, if you like, Mike, I think, Newell, maybe you can correct me, who was actually one of the first people working at CAD Centre. It's a Cambridge University spin-off in UK. We then went forward and developed the world's first 3D plant design system. It looked a bit like this for designing process plants, chemical plants, oil refineries, this kind of stuff. We got color and shading as the hardware improved. And these days, this is what our technology looks like. This is a model kindly provided by Shell, but it's a whole oil rig there displayed on our technology, touchscreen interface, all of the information behind the scenes. The way that our industry works, like the previous speaker, Guido, is a little bit different from some of the other speakers you've seen, Boeing and the automotive manufacturers, because our customers make bespoke products, made-to-order products. So just to give you an example, again, the kind of scale of the products that our customers make, this is actually two things. It's not two ships. It's the world's biggest ship, Pioneering Spirit, made by DSME for all seas. And this ship can literally come along and lift up an oil rig off its legs. It can lift 50,000 tons and take it back and decommission it. And the oil platform here, which has a kind of black history, but this is a small one, 13,000 tons, also made by our customer, SBM. So some interesting things about what our customers do with software that basically give us some challenges when we come to making AR and VR applications. So as I said, these projects are pretty much one-offs. There's no production line, there's no factory that build these things. They're all fabricated. And on something like this is a kind of example oil platform. There's probably like 200 to 400,000 individually fabricated items. So there's no production line making the same thing hundreds of times. There are millions of attributes. There are tens of thousands of drawings associated with this. And perhaps most interestingly, our customers spend millions of man-hours to build these wonderful 3D models. But the weird thing is, even though they build these wonderful 3D models, they still use drawings as the main communications medium. So they use drawings to show design intent, they use drawings to capture changes, they use drawings to communicate to workers what they have to do in the field. And drawings are kind of really convenient because you can carry them with you. They're, I think, loved the most because you can stamp a drawing and say, yes, this is an approved document, and that's the main reason why they're used. But as you may have heard from some of the other presenters, drawings are kind of out of date. As soon as you print that drawing out and the CAD model gets changed, then you're working from bad data, and that's a big problem in our industry. So luckily, we're living in an age where we have this fantastic immersive visualization technology, which we believe is totally going to change the game in terms of how people work on the construction sites, how they work in operations, and all these wonderful things. So immersive visualization is not a new thing for our industry and not a new thing for our company. This is 1997. I thought it was 1967 or something, but it's actually 1997. And this is our Silicon Graphics Reality Cave. The Silicon Graphics machine cost over £1 million British pounds. The joystick alone cost £2,000. So this was a very expensive facility, but even though our world uses drawings, management would pay to come and use this facility because access to 3D was so critical for them to make these very big decisions about these engineering projects. Today, every single user on a project potentially has access to one of those virtual reality caves through headsets like HTC Vive. So this is a quote I kind of stole, but this is something that's very significant. So instead of 3D being accessible, so stereoscopic 3D being accessible to the management and the VIPs, it's accessible to every single designer. And some of our customers have 2,000 designers. The use cases of this are kind of obvious. So it's checking design, it's checking ergonomics, checking for safety, and so on. And we already have customers starting to use this in design review. Augmented reality, on the other hand, and this is a screenshot from our HoloLens demo, has huge potential. It basically allows you to bring with you the digital twin or the digital asset into any job that you do. And of course, like other speakers have said, most of these use cases are in the field. So it's inspection, maintenance, commissioning, fabrication, these kind of things. So for our industry, the use cases are actually pretty straightforward. There's a very strong use cases already there in our industry. So just to kind of summarize where we are, and this is kind of primarily oil and gas, power generation, shipbuilding. 3D has always been, I say always, but for decades 3D has been used in the design and construction process, or design and fabrication process. With augmented and virtual reality technology, this is going to drive a new wave of adoption of 3D into maintenance and operations. And that's a very significant thing. It changes the game for many of the players in this industry. But it's not all a straight road. There are challenges, and you'll see kind of common themes in these challenges. Especially for our industry, model size is a big problem. So customers, sometimes they want to see the whole model. It's as simple as that. They want to see the whole goddamn oil rig on their screen. And these things, we're talking tens of millions of polygons. They're not modeled to the micron detail that cars are, but there's just lots of parts in there. So model size is a problem. We've had our own problems trying to build HoloLens applications that will read oil rigs and display that kind of thing. But the second one, which I want to dwell on, which is very important, and some people have brought it up, but it's basically the fact that getting a 3D model, a CAD model, into an environment where you can build an AR application, or potentially also a VR application, has a horrible production pipeline. This is a kind of game technology terminology. But basically, you have to convert the CAD model into some kind of mesh format. You usually lose colors, and you might lose the hierarchy of the model. You usually have to simplify it. And this is a real pain in the ass. And I've got some numbers for you that you can quote, but on a couple of projects we worked on, this is like 150,000 K of services in a low-cost country to do this. And that's for kind of every project. And that's just to convert and simplify, a whole oil rig. The most important thing is that when you convert a model and you decimate it, you're disconnecting your augmented reality or virtual reality application from the digital asset. And that's completely against what the executives are trying to do in the companies that we work with. So integrity of the model starts to become compromised as soon as you start copying a file, making it a visualization kind of data. Now, the other challenge that we faced is kind of a unique one as a software developer. So we make software products, but as soon as we started talking to customers about augmented reality applications, they would say, great, HoloLens, we want a commissioning app, we want an app for training people, we want an app for sales, we want an app for inspection. And because these applications are so bespoke, we can't possibly make all these hundreds of applications for every single company that we serve with our engineering tools. So you basically need, forgot my slides. The visualization performance thing, I think we've got cracked. So this is our own rendering engine. This is, again, the shell model. This is a very large model in terms of polygons, but we're able to, fly through this with an Oculus at a very good frame rate. So that's just a small example. And that runs 52 million polygons, approximately. I've interpolated from a smaller model, but that runs nicely at 90 frames per second. So we've got the model performance thing solved from our side. This comes from a single data from the CAD system. It's going to come directly from the CAD data as soon as we've got our service that can produce this this data on the fly finished. But basically, the production pipeline, we start to solve that problem from our side. But as you know, a lot of the applications, especially for HoloLens, are built with game engines, Unity specifically in this case. And that's because they allow you to add interactivity, they allow you to add various special effects, and very importantly, as you've seen from Boeing and other speakers, they allow you to deploy to different platforms, to tablets, to head-mounted devices. So, you know, our idea, and this is something that I think industry could be interested in adopting generally, is that, okay, from our point of view, from a software point of view, we make software that allows you to create the digital asset, so an oil rig model or a ship model, and that allows you to perhaps manage the data associated with that, the engineering attributes, that kind of thing. And then we've got the world where most of the augmented reality applications are developed. So it's Unity in this case. I think the Unity Asset Store will become much more enterprise-friendly with enterprise-ready assets in there. It's not the case today. And our idea is simply to connect together our platform, our digital asset platform, with an SDK that serves up graphics, engineering data, engineering documents, and reads back into the CAD database things like markup and redlining that might be done in an augmented reality application. And if you kind of extend this idea, we're seeing that augmented reality applications are used in operations mostly, or on the field. It kind of makes sense that the developers of Internet of Things softwares or operational software, like Predix from GE or MindSphere from Siemens or OSI Soft, do the same thing, so that those augmented reality applications have access to, you know, enterprise-level operationals data, allowing effectively this ecosystem of developers, many of you here, to create all of these bespoke and custom augmented reality applications, yet retaining the link to that enterprise data in the back end. So again, we've started our work to do that. This is the same shell platform running in Unity. So we've basically started with the graphics integration. This data is coming one step removed directly from our CAD system, but we can render this same 52 million triangles in Unity at 60 frames per second, which we think is pretty good. And of course, from this, you could develop a Unity application that you can send to your customers and that kind of thing. So to summarize, the immersive digital asset, so realizing this immersive digital asset that's going to be accessible from head-mounted devices and VR, critical to do that is really to connect the immersive digital asset to the master 3D data and engineering data, connect it to the operational data, but do that in an environment which is accessible to AR and VR developers. And in our case, that's through Unity at the moment. So that's all I've got time for. Thank you very much for your attention.